Hello, Jim Houlis here, wearing the same shirt I always wear. Today we're going to look at a polar molecule as compared to the nonpolar molecule we looked at, CO2. So we do the Lewis dot structure in the same way. We have two H's. They each contribute one valence electron. And you get that from the periodic table. C, there are two of them. They each contribute 4 valence electrons. The fluorine, there are two of those, and they each contribute 7 valence electrons. So you have to multiply each one of those by 2, so we have 2 plus 8 plus 14 for 24 valence electrons. All right? So how do we draw this Lewis dot structure? Well, we have to know that because of this positioning here, these two are attached to this carbon, these two are attached to this carbon, and the two carbons are attached together. So let's start with the first carbon and put our 4 electrons around it, right? I always like to put them around before I start making bonds. Now, since this carbon has 2 hydrogens, let's put those in. All right? Now, let's put another carbon in. 1, 2, 3, 4. All right? Let's put our fluorines in. Fluorine has 7 electrons. 1, 2, 3, 4, 5, 6, 7. This fluorine, 1, 2, 3, 4, 5, 6, 7. Well, it all looks pretty good. Let's count it up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23, 24. However, around the carbon, I only have 2, 4, 6, 7. Around this carbon, I only have 2, 4, 6, 7. But I do have these 2 lone electrons. I'm going to bring those in. And when I do, I end up with this. Double bond, and then the fluorine with the 3 lone pairs bond to the carbon like this. So now I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 electrons, just like I'm supposed to. So I've used all my valence electrons. I now have the structure for this, which, when you write the structural formula, becomes this model right here. So we have a double bond and 2 single bonds. If you look this up in your lab manual, you'll see that the shape for this is trigonal planar for both carbons. If you look at just one side, this side, right, you have this double bond and then 2 single bonds. That's the trigonal planar portion. If you look at this side, you also have a trigonal planar portion. Now, if we do the electronegativities, this one's slightly negative, this one's slightly positive. On this side, they're covalent. They're just shared equally. These are polar covalent. So overall, you have electron pulling this way, more electrons pulling this way than pulling that way. So this is non-symmetrical. Or polar as an entire molecule, as compared to when we look at the polar bonds on carbon dioxide, which, because it was symmetrical, led to a non-polar linear molecule. Thank you for your attention.